Hi everybody, Mike from the Digital Media Lab here today to talk to you about pixels per inch or PPI, dots per inch or DPI, and some of the caveats when working with these kinds of concepts. Now you'll need to understand these ideas when talking to designers and printers and other people inside of the digital media profession. Let's get started. The first thing you need to understand is what a pixel is. Most of us understand this already. However, a pixel is essentially dividing an image into a grid and each brick being its own individual color. Now, pixels are usually so small that our minds combine them into smooth gradients and colors and other images, so we don't actually see them. However, if I take my magnifying glass here, which I have here, and I press it up against my monitor, I will actually see the pixels. Each one of those red and green bands is a pixel. Now when it comes to monitors and other display devices, pixels are largely fixed. The number of pixels per inch that your monitor contains is set. So pixels per inch is irrelevant for monitors and other projectors and other kinds of display devices like that. When we're talking about pixels per inch, the takeaway that you need to understand is that PPI is a way to adjust physical size. Let me demonstrate that. Here I have a 100 by 100 pixel image at 100 PPI. And if I zoom out a little bit here, we can see that it is 1 inch. There's one right there. And another inch. So 1 inch by 1 inch. If I go into my image size dialog box here, and I need to uncheck resample. If I change the resolution from 100 to 200, if I double it, the amount of pixels that I have available there to print are now in half. So a 1 inch by 1 inch document at 100 pixels per inch printed at 200 pixels per inch is actually only going to be able to be printed at 1/2 an inch by 1/2 an inch. Likewise, if I take my 100 pixel per inch image and I lower its PPI, I can double the amount of area that I can print. Now usually pixels per inch also determines the quality of the print that you're going to be receiving. Usually you never ever want to print lower than 200 PPI. And typical printer ranges are between 200 PPI and 300 PPI. 300 PPI usually being for print quality. Magazines usually run at about 266 PPI. Now dots per inch or DPI, while less important for you to completely understand, is the realm of printers. And excuse me while I look up something. It's really the realm of printers. And if I take my microscope here, let me change my program. And I have a piece of print here. I turn on the lights. There we go. We can actually see that dots were printed. Now, DPI is largely a technical aspect of printing, and you won't need to worry about it too much. Let's look at a practical example of some of the things that are going to be involved when you're thinking about PPI. Here I have an image that I pulled off the internet of a kitten, And this is probably one of the more common problems that happens, is an image from the web doesn't contain a particularly large number of pixels. But remember, we need quite a few pixels, 200 pixels per inch, in order to print it. If I wanted to print this at a minimum print resolution of 200, my 8 by 6 inch document, or picture of a kitten, would now only be 3.2 by 2.4. Likewise, at 300 pixels per inch, a higher quality, frankly, for an image like this is what I would want to print it at, I would only have 2 inches by 1 inch. Images from the web typically do not print well. There's just not enough pixels there for you to be able to print. I know what you're thinking, that you have printed things that size. No matter what, when you try to print an image that doesn't contain enough pixel data, one of the things that your computer is going to have to do, or a computer is going to have to do, is add more pixels. So this is actually an option inside of Photoshop. I can actually take my 72 pixel per inch image and increase the resolution to 300. However, when I do that, and I'll go ahead and click OK. Let's let Photoshop run there for a second. I now have a large amount of pixelization. This is because computers, no matter how powerful they are terrible at understanding what this image is. It doesn't understand. My computer doesn't understand that I'm looking at a cute kitten. So what it has to do is it has to guess what pixels go where. It doesn't do a very good job of it, and probably never will. No matter what you do, if you pull an image off the web, it will have to do this. It will have to guess, and it's not very good at it. Inside of PowerPoint, we can do the same thing. Whenever I click and drag one of these handles here, I'm telling PowerPoint to guess at the number of pixels. Now, one of the things that computers are actually pretty good at is throwing away pixels or reducing the size of an image. That is pretty much almost always okay. However, increasing an image, figuring out adding pixels, not as good. One of the other common things that I see students doing all the time, this is a hallmark of pretty bad design. In any format, whether it be for print or for your monitor, never, ever, ever stretch your images like this. Inside of PowerPoint and inside of Word, that means grabbing one of these center squares like this. You always, always, always want to grab from a corner, because you want to maintain what's called aspect ratio. Or basically, I want my box to remain the same size, or at least the same sort of ratio, so this width and height are going to stay the same. But if I stretch an image, it always, always, always looks bad. Never ever stretch an image this way or this way. That's it, everybody. Thanks for watching.